All right, guys. So now I'm going to do number 2 of the week 9 worksheet. It's a simple probability question about a standard deck of 52 playing cards. Okay, and if you remember, we gave you guys these little half sheets that tell you all about a card deck in case if you're unfamiliar with it. So let's begin. So the first question is, what's the probability that you would get a heart? Now, the very first thing that we want to know is that there's a total of 52 cards in a playing deck. So automatically, I know my answer is going to be out of 52, okay? Because there's 52 total cards. Now, what's the probability that I choose a card that's a heart? Well, the hearts, there are 13 of them. There are 13 of each suit, in fact, but there are 13 hearts in a playing deck. So I would say that would be 13 out of 52. Now, we have to make sure that we simplify our fractions at every opportunity that we can get, okay? So I want to simplify this fraction. I want to reduce it. So what I'm going to do is I'm going to divide by something that goes into both 13 and 52. Now, I know that 13 goes into 13, and I also know that 13 goes into 52. So what that leaves me with is 1/4. That's my answer for the probability of pulling a heart. So now on to the next problem. So that was A. B asks, what's the probability that you would pull a face card? If you're unfamiliar, a face card, there's 3 of them. It's Jack, King, and Queen. Sorry, Jack, Queen, King, right? There's 3 of them per suit, and there's 4 suits, right? So that means that there's 12 of them total in the deck. If you don't believe me, you can count it. But there are 12 in the deck, which means that there's 12 out of 52. So now I need to reduce this, right? What number goes into both 2 and 52? First one that I can think of is 2. So I'll divide by 2 on both of them. So that gives me 6/26. But I'm not done yet. I can still reduce this more. So I'm going to divide by 2 again. And what I get is 3 out of 13. That's as simple as we can get. So that will be the probability that I get a face card. Now, part C. What's the probability that I get a heart and it's a face card? So now there's 2 ways to do, or sorry, there's not 2 ways to do these problems. Let's go back to our sheet here. So what's the probability that we get a heart, right? Well, that's all of these in this entire row. But we don't want just a heart. It has to be a heart and it has to be a face card. So that only leaves these 3 left. These 3 are both hearts and face cards, okay? So that leaves us with a 3 out of 52 chance, okay? And that's as simple as we can get. All right, so what I did, just to remind you, what I did was I had this entire row counts as hearts, and this entire block right here counts as face cards. So I take the intersection of those. I count only where those both intersect. So these 3 right here, these 3 columns, and this 1 row. Where do they intersect? Boom, boom, boom. These 3. So that tells me that that's 3 out of 52. Okay, let's move on to part D. What's the probability that I get a heart or a face card? So last problem, heart and a face card, this is what we call an intersection. Remember what I showed you? I showed you those columns and those rows, and I pointed out where they intersected, right? These 3 columns and this row, they intersected right here. Now, OR questions, these are what we call unions, okay? So what these are is it's everything in these 3 columns and everything in this row. So there's 2 ways to do this. The first way is we can literally just count up all of these and all of these hearts, okay? And that would get us the right answer. We could do that, or what we could do is we could take the probability that we get a heart, we add it to the probability that we get a face card, and then we subtract where they overlap, which would be the hearts and face cards, which is what we found last problem. Okay, so why do I do that? The reason why I do that is because, first of all, I would count the probability that I get a face card, which would be all of these, and then I count the probability that I get all of these in this row. But what I just did was I just counted these three, this intersection, twice. I counted them once when I went here, and I counted them once when I went here. So if you're going to do it that way, you need to subtract that intersection so that you only count it once instead of twice. So I'll show you how to do that. That would be that would be 1 over 4. In fact, I'm going to use the 52 denominator because it's going to be easier to combine. So forget I said 1 over 4. I'm going to use 13 over 52 plus probability I get a face card is 12 over 52. And then I'm going to subtract where they intersect, 3 over 52, okay? So that would be 13 plus 12 is 25. 25 minus 3 is 22 over 52. Now I need to reduce this, so I divide by 2, divide by 2. I get 11 over 26. That's as far as we can go. Okay, so that's the answer to part D. Part E, what's the probability that you get something that's not a heart? So sometimes, and we didn't really talk about this much in my class or in Miss Ibrahim's class, but this is called a complement. Okay, you won't be tested on the name of it, but what a complement says is that sometimes it's easier to calculate something, to calculate the opposite of it, and then subtract it from 1. So I could come in here and I could count up all of the ones that aren't hearts. I could count up all of this row, and all of this bottom row. Or what I could do is I could just count up this row that has all the hearts, and I could subtract that from 1. So I'm going to do that. I'm going to do 1 minus, and then what's the probability we get a heart? Let's go back up. It was 1 over 4. So 1 minus 1 over 4. I'm going to make the 1 into a 4 over 4 so I can subtract it with a common denominator. What I end up with is 3 over 4. That's my chances of picking something that is not a heart. Okay, part F. What's the probability that I pull a black card? Okay, let's take a look. So, as we see here, the clubs are black and the spades are black, right? Those are 13 each, which means 13 plus 13 is 26. 26 over 52, right? And we can reduce that. That'd be 13 over 26, which we can reduce even more to be 1/2. Okay, so that would be my answer. Part G. What's the probability that I pull a 10? Okay, so remember there's 4 suits. Here's a 10, here's a 10, here's a 10, and here's a 10. So that's pretty simple. It's just 4 out of 52. Okay, we can reduce that, divide both of these by 4, and that becomes 1 over 13. Okay, I'm going to grab another piece of scratch paper real quick. Also, feel free to pause these videos whenever you need to, or rewind them. Okay, part H. What's the probability that I get a black card and it's a 10? So it has to be 10 and it has to be a black card. So let's look back. Here are my 10 cards, right? They're all in this one row. sorry, column. They're all in this one column. And then these 2 rows are our black cards. Okay? So I'm looking for the intersection of this column and these 2 rows, which would be these 2 cards. So that would be 2 out of 52. I can simplify that. So that would be 1 over 26. That's my answer. Okay? Moving on to I. What's the probability that I have a black card or a 10? So going back to our previous problem, this was an intersection. Because it says and. That's the key here. If it says and, it's an intersection. If it says or, it's a union. Okay? So it's the probability I get black or a 10. So let's look back here. So these are all my black cards. And then these are all my 10s. So instead of doing what we did before, I'm just going to count them up. Okay, so remember there's 2 ways to do this. I'm going to count them up this time. I'm going to do them the different way. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I got 28 out of 52. I can reduce that. I divide both by 2. That would be 14 over 26. I can go even farther. I can divide by 2 again. That'd be 7 over 13. Oops, that's as far as we can go. Okay. Now, finally, part J. J is a challenging one. So what's the probability it's not a black card and not a 10? Okay, so what's the probability it's not a black card and it's not a 10? So it can't be either of those. It can't be a black card and it can't be a 10. If it's a black card, I don't want it. If it's a 10, I don't want it. So let's take a look real quick. The probability that I get a black card, right, are all 13 of these and all 13 of these, right? So those I can throw out. And then the probability I get a 10 are 2 more of those, right? So that'll be 13 plus 13. Write this out. Plus, again, these 2 right here that we didn't count. All of those over 52. You could write over 52 each like this. That would work. But the key here is that these are the ones I don't want to pick, right? So what are the ones that I do want to pick? Looking back to our previous problem E, right, with the complement deal, I found out the ones I didn't want first. Then I subtracted them from 1. So these are the ones that I don't want. So what I'm going to do is I'm going to add those up, and I'm going to subtract them from 1. Okay, so whether or not you choose to do it this way or this way, doesn't matter. Just make sure you subtract it from 1. So I'm going to choose to do this one. 13 plus 13, 26, plus 2 is 28 over 52. I'm going to change the 1 so it has a denominator of 52, so I can subtract them. So that'll be 52 over 52, and I'm free to subtract them, okay? So that would be 24 over 52, okay? I reduce that, divide by 2, divided by 2. That'd be 12 over 26. I can reduce it further. I divide them by 2 again. That'd be 6 over 13. That's my probability of not drawing a black card and not drawing a 10. So that's all of problem 2. Let me know if you have any questions, and that's about it.